So for my nitrogen cycle project, I had the really nerdy idea to do a study with me on the topic. So in this video, I'll just be making a mind map explaining the nitrogen cycle. In this first clip, I'm just drawing out the nitrogen cycle diagram that's in the book. First, nitrate ions from sewage, manure, and fertilizer dissolve into the soil, which is then collected by runoff, where it flows to the reservoir of dissolved nutrients, aka the ocean. There, denitrification occurs, causing the nitrates to become nitrogen gas in the atmosphere, where it will later dissolve back into the sea and undergo nitrogen fixation and become a usable form for most organisms, such as ammonium. There, it undergoes nitrification and is uptaken by marine organisms who then die, decay, and sink to the bottom of the ocean, causing the nitrogen compounds to become incorporated into the seabed. During the process of upwelling, all the nitrogen compounds in the seabed will rise up in cold, nutrient-rich water to be brought back to the ocean surface where the cycle will begin again. Nitrogen is primarily used to build amino acids, proteins, DNA, and RNA for the nitrogenous bases. It's a limiting factor for growth for plants. What I find most interesting about the nitrogen cycle is the involvement of bacteria and plankton in the process, and how all of the organisms involved are chemoautotrophic, because the chemicals that assist in denitrification and nitrification only occur in the presence of very little oxygen. In order to use nitrogen, organisms such as diazotrophs must convert it into usable forms such as ammonium. Diazotrophs do this through the process of nitrogen fixation, which requires a nitrogenous enzyme that only operates in the presence of very little oxygen, which is why these bacteria are always going to be chemoautotrophic. So little to no photosynthesis can take place in nitrogen-fixing bacteria. After the ammonia is made in the process, it dissolves back into the water to form ammonium ions, which phytoplankton use to convert to proteins. Most phytoplankton use nitrate or nitrite ions for this process because they're more available in the water than ammonium, but they also use ammonium. The proteins made by the plankton will be passed through the food chain, digested by consumers, and they'll be incorporated into amino acids used to build proteins. When organisms die, saprophytes break down the proteins into amino acids. These amino acids convert back into ammonia by specialized bacteria. Ammonia is later oxidized into nitrates and then nitrites in the process of nitrification. The organisms, plankton, dealing with the different conversions of the nitrogen cycle are always going to be chemoautotrophic again because of those nitrogenous enzymes that assist in the processes. Nitrogen is added to the ecosystem mainly by fertilizer, sewage, manure, upwelling, runoff, and dissolution, and it typically reduces productivity. The bacteria involved in the nitrogen cycle are going to be diazotrophs, saprophytes, and other specialized nitrogen-fixing bacteria, and nitrogen is primarily useful in the formation of proteins, amino acids, DNA, and RNA.